Okay, so good day, class. I think we have already made a lot of lectures regarding the basic theories and principles in concrete and steel design. So, this stage of our study, we're going to focus on you procuring and drawing the various details that are needed uh, when you do structural plans. Okay, so for for this week, we're going to discuss something about the foundation plan in relation to drawing it. Okay? So for the first page of your structural class, you can find your ground floor foundation plan. Here you can find the different footing details and how the rebars or reinforcements will be arranged in your project. Okay? So if you notice, class, most of the reinforcing bars are 16 mm. Okay. I think as far as I can remember when I took the review back in 2009, the minimum rebar requirements for columns is around 416 millimeter bars, according to the structural code of the Philippines. Okay. But it would also depend maybe on the recommendation of the structural engineer, because as long as the area of steel is equal to the strength that is required, I think that will suffice. Okay. So here, C1F1 plan detail is around 1.5 by 1.5 meters. So it means it's column 1, footing 1. Then we also have column 2, footing 2. Okay. So let's blow this up and see what are the differences. Okay, so I can zoom. Okay. Now I can zoom. Just make this bigger, class. Okay. Just wait. So I can't make this bigger. So I'll just download the picture, class, and let's discuss it there. Okay, showing folder, structural S11. Okay, this is okay. This one. Okay. Now let's discuss this in detail. Okay. Here, this is the C1F1. So there's 8 16 millimeter vertical bars going up, and then the size of the column is 0.15 by 0.4, and the size of the foundation is 1.5 by 1.5. Here in column 2, footing 2, the size of the foundation is 1.2 by 1.2, and the size of the column is around 1.5 by 0.4. I know it's 0.15 by 0.4. Okay. Um, okay. It's still 12 millimeter. Okay. So the dimension, class, is the same. So the dimension, class, is the same at 0.15 by 0.4, but the difference are in the vertical bars. So here there are 8 12 millimeter vertical bar reinforcements, and but here there are 8 16 millimeter bar reinforcements. So I think that's the main difference. Then also the difference would be the size of the foundation, because here it's 1.2 by 1.2, while in the C1 F1 it's 1.5 by 1.5. Okay. Then, but we also have others. Like here, there's a different detail for C2 F3 in this location. I think this is the firewall. Okay. So when you design your houses, last, always make sure that the firewall does not, I mean, your foundation does not encroach the property line, because you can only build your structural supports or your structural elements only within the property line of the building or structure. Okay, so we have F2C3, F2C3, F2C2. Then we have another design which is F3C4. Okay, now let's move into the next. Okay, so I think you can find F3C3 here. Let's So this is C3F3. So the size is 1.25 by 1.25, and the size of the columns is around 0.25 by zero point 0.3 with 8 12 millimeter vertical reinforcements. And C4F3, it has a size of 1.2 by 1.2 with a column size of 0.15 by zero point 0.4 and 6 12 millimeter reinforcements. Okay, so this is a section detail. Here you can find the natural grade line, which should be verified. And here you can find the footing tie beam. Okay, so your tie beam class, I think it's really important so that your structure underground is or overall connected. Okay, so that if there's a movement in the soil, okay, then if it's connected, then it won't sink like this. Okay, so there's a tendency, class, that if you won't place an I-beam, the other columns might, if there's a movement had in the ground, what if one of the columns goes down due to the soil, then the entire system will be affected. Okay? Just because of that movement. But if your entire column system is connected by tie beams, so it's one whole system connected together. So even if there's a movement in the ground, since it's already connected, it won't just sink. Okay, so you have the problem of one of the columns sinking if there's a movement in the ground if you don't connect it with tie beams. But of course, it will depend on the quality of the soil and the computation. But generally speaking, if you are building in areas that are there's quite lot of moisture in the ground, then the soil is soft, I would just recommend that for you to place a footing tie beam. So here you can find the schedule of footing and column. If the for instance, in the mark of F1 with the width and the length, the dimension, then the long direction, then the short direction, then the remarks. It's an isolated column. Okay, so isolated meaning it's not connected. Isolated footing meaning it's not connected with the other footings. Because you also have what you call combined footings. When the two columns are too close together, you combine the footings into one. Okay. So here in the C1F1 section detail, you can see class how deep, how no, how thick the foundation is. Then you can see the gravel base. Okay. So after excavation, you compact the soil, then you add the gravel base before you're going to add uh, the foundation. Okay, now let's go to the next. Okay. So I think you can find here the footing tie beam detail. So here the stirrups, and this is the section. It's zero point 0.2 by zero point 0.3. So you're just going to use 10 millimeter stirrups. Then wow. So in the footing tie beam, they're going to use 16 millimeter bars. So this is really strong. So the C1F1 section, WF1 section detail, full footing one section detail. Okay, this is just for the wall footing. We're going to use your concrete hollow blocks. But the problem with hollow blocks class when you implement it in construction is that you have to be really attentive on the way it is piled and check its leveling. Otherwise, most of the time you'll have a problems uh, when you're already doing the finishing work. Okay? Because if the finishing is too thick, I think there's a tendency for it to crack. So that's the cause of hairline cracks. Right now, class, what we use in my construction project is what you call the fast wall system. So we use what we call the precast panels, which has a thickness of around point 0.075 meters or 75 mm. So it's just one whole system. Okay, so let me show you a video on what I'm talking about so that you can visualize it. Okay, class, so this is an example of the fast wall system. So I think we'll use this in one of our construction projects. So standard size is around 2.44 by zero point 0.6, and the thickness comes in 75 millimeter, 90 millimeter, 120 millimeter, and 150 millimeter. Okay, so this is the material composition of it. So it's fireproof, it's water resistant, moisture proof. It has also heat insulation, and it's lightweight, and it has effective sound reduction and temperature preservation. So it is better than the traditional CHB as claimed by the company. Okay, so let me show you the tools that are needed. So you just need these tools in the installation. Okay, so let's just move. Okay, panel installation. Okay, so here class, I think it's better if you see in actual what it would look like. So when you install class, if as you can see when you do your traditional CHB, you have to pile it layer by layer. But with fast wall system, I think they could just install around 36 square meters in a day or two, which make it faster. And then another advantage is that when using this system, you don't need to add the plastering anymore. Then you won't have the problems of hairline cracks. Okay, so after you paint that, it would generally, I think it's I've been in the product presentation. It would generally be really straight, okay, and plumb. Okay, I think this is one of their projects also, and I'm planning to use this technology in a project as well, just to test. Because when I arrived here in the Philippines last, one of the problems that I saw was really with the construction materials, especially with CHB. So when you line up CHB, you can't. It's really hard to monitor the people that are installing it that are call this piling it in the site. So it's hard to get make it plumb. If you can't get it plumb and it has a certain deviation, then you're going to spend a lot in plastering. Then even if you spend a lot in plastering, another problem is that after painting, there could be hairline cracks. So with this system, it's already those problems are already eliminated because it's easier to check the plumbness of your wall. Plus, as per test results that they gave me, it is I think 2 times stronger than the traditional CHB, which makes it gives it a lot of advantage. Okay, so that's it for my sharing class. So our activity for this week I will post it on our page. So I'll give you around 2 weeks to prepare the working drawings. So this will be our lecture for week 3 and 4, and we will have online consultations if you will request it during our time. Okay, especially if you have questions in your drafting. So it's really for me, class. It's really hard right now in the pandemic for laboratory subject because I can't really monitor you when you do your drafting. I'm not even sure if you're the one who drafted your plates as well. But I'm sure, class, that by next year things will be getting better and better. Okay, so if you have any further questions and clarifications, just don't hesitate to approach me, class. Then stay safe and see you in our next lecture.